Hello and welcome to Big Ideas Blue Math. I'm Mr. Thayer, your 8th grade math teacher. Today we're going to discuss proportional relationships. Let's go. So for our warm-up today, I'm asking you to solve these proportions. So using the knowledge you already know, I would like you to solve for the variable. Find the value of x for numbers 1, 2, 3, and 4. Please complete this warm-up right now, and we'll come back to the answers in just a moment.
You would do the 6 times 2 to try and get the 6 times 2 to get the x, because and then it would equal to 12. So you know that x is 12.
A little bit of cross multiplication here, right? So x is equal to 12. Yeah, use that magic cross multiplication tool and solve the remainder of the problems in your warm-up. Go, go, go. 3 times 24 and number 2, okay.
And then you would do 4x.
4 times x, all right. And 3 times 24 is 60 plus 12 is 72. And what will we do next?
Now you would divide 4 on both sides.
Okay. And x would be 72 divided by 4, is that 18? Yeah,
Yes.
nice. Thank you. All right. Anyone have an idea for number 3? Thanks, London and Matthias so far. Number 3. Go ahead, Lauren. You got to unmute yourself, though, Lauren. If you're going to talk us through number 3.
You would cross multiply 2 and 18 and 6 and x.
All right.
So that would be 36 equals 6x.
Okay.
And then you would divide 6 on both sides
Awesome.
to get 6 equals x.
Very good. Okay, who's going to take us home on the last one here? Someone new. Thanks, our volunteers so far. Let's finish this warm-up here strong. All right. Would you help us out here, Robbie? Number
Sure.
4?
So you have to multiply 8 times 3 and 12 times x. So then that's 24 equals 12x. And then you have to divide by 12, which is 2x, or x equals 2.
All right, thank you so much. Nice job, everyone. Thanks for volunteering. Today, you will discover characteristics of proportional relationship. So you're going to learn what it looks like on a graph, for example, or in a table. 2, you will learn how to identify proportional relationships from a graph, a table, an equation. And 3, learn other phrases for the word proportional. Okay, so let's take a look at our first example here. Let's work together. And this one right here, don't copy anything down. Let's just look at the screen together. The question says, do the points on either graph form a proportion y over x? So you just did a warm-up. So check this out. What is the coordinate of that point right there? What is the coordinate of that point right there? Taylor Hartwig, for this graph, what coordinate is that?
2 and 20.
2, 20. All right, and Helen Fairbanks, this coordinate right here, what is the coordinate for that right there?
550.
Nice job, 550, okay. All right, do either of these points form a proportion? So it says y over x, so let's take these y values and put it over the x value like that. All right, we want to see, are these going to be equal to each other? Because that's what we know about proportion so far. It means equal. So it's 20 over 2, well, that's just 10. And 50 over 5 is also 10. Yes, they form a proportion. That's one way of proving it. Just take y and divide it by x and see if they're equal to each other. Hop on over to the second graph in this picture. Skylar Lindstrom, what's the coordinate of that point right there?
240.
240. And so as you're writing in your notebooks right now, you don't need to copy the graphs, but I would write these points down and show what we're doing with the points. We're trying to see, does y over x equal y over x? So we got 240, and Emily Cyric, what's this other coordinate here?
6 over 100.
6, 100. So we're going to write y over x, so we'll put 40 over 2, and see, is that equal to 100 over 6? And so we learned in the warm-up to cross multiply to prove if things are equal. So let's try that method this time. Let's cross multiply. One method is to reduce like we did over here on the left. Another method is to cross multiply. So is 200 equal to 6 times 40, which is 240? No, those are not equal. So these are not proportional. All right, so that's the ones where we work together here. Let's take a look at something new. All right, so let's continue to explore our examples of proportional relationships. Let's take a look at the next one. Do the points on either graph form a proportion? Okay, now you want to try these on your own. Just like we did before, go ahead and try and figure out using the coordinates on each graph if y over x equals y over x, just like we did in the previous example. So I'll pause and we'll come back to you in a couple minutes. All right, welcome back to the big show. This helicopter problem, talking about the height of the helicopter as time goes on in seconds. Looks like we maybe have a helicopter that's landing. The first set of coordinates is 225. So at 2 seconds, the helicopter is 25 meters in the air. And the second set is at 510. 5 seconds, the helicopter is 10 meters in the air. Let's see here. Ian Cook, do these 2 points form a proportion? In other words, is 25 over 2 equal to 10 over 5? Ian, we eagerly await your response.
No.
No, because 125 is not equal to 20, right? These do not form a proportion, so this is not proportional. Let's jump over to the one on the right, talking about going on a walk, time going on, the more miles you walk. This is a long walk, people. Our first coordinate, 1 hour has passed by and you've walked 4 miles. Our second coordinate, 4 hours have passed by and you've walked 16 miles. Whoa. All right, so do those 2 points have enough information to form a proportion? What do you think, Ava Hillman?
Yes.
Yes. Okay, let's compare the y over x, right? 4 over 1 is 4. 16 over 4 is 4. You see, we don't always have to cross multiply. It's just a tool that we can use. Yes, these are equal. They do form a proportion. And take a look, Robbie. This one crosses through the origin, and this one did not. I wonder if we're onto something there. Let's proceed. Questions on this? Okay, what do the graphs that form a proportion have in common that other graphs do not? Go ahead, Matthias.
They all start from the origin,
Bingo.
and then the other ones, they don't start from the origin. They start from like 10 or whatever.
So in your notebooks, proportional graphs have 2 main characteristics. They are straight. In other words, they're linear. And they pass through the origin. So these ones are proportional on the left. They pass through the origin and they're straight. Now the ones on the right, they are straight, but they do not pass through the origin. So they're not proportional. Okay? All right, so they are straight and they pass through the origin. That's what makes graphs proportional. Okay, so there are some other phrases that are used in math that mean the same thing as proportional. I just want you to see them on the screen, and you can write these down as well. Proportional is the same thing as the phrase directly proportional. So write that first phrase down. To be directly proportional is the same thing as being proportional for now. That means as x changes, so does y in the same manner. If I boost the value of x, the value of y also goes up. Another phrase is direct variation. Same thing as proportional in this chapter. And finally, the third phrase is y varies directly with x. That's the final phrase you want to write down. All three of these could swap out for this word while we're in this part of the chapter. All right, giddy up, here we go. So here's an example of some tables right here. We want to know, do the tables have points that form a proportion? So to put really simply for these, without copying down the tables themselves, what you can do is explore with me exactly what we did in our warm-up. Our warm-up was all about y over x, right? So let's do it. Let's do y over x and see if they're equal to each other. So let's pick some x and y values. So let's do 90 over 1 and pick another pair, doesn't matter. Pick the very next one and see if that is equal to 200 over 2. Now remember, you can simplify or cross multiply to do this. I'm going to choose simplify here because 90 over 1 is just 90. And 200 over 2 is 100. So I know those are not equal, so they are not proportional. All right, let's jump on over here to the other table. Pick any 2 points in this table and let's see if they form a proportion. All right, I'll let you choose, audience. What do you think? Riley Kaplan, what 2 points do you want to grab from this table on the right to see if they're proportional?
2 and 4 and 1/2 over 1.
All right, so we'll choose these two. And so we'll do y over x. So this first point, we'll do 1 over 1/2. And we'll see if that is equal to 4 over 2. Remember, it's the y's on top. Okay, so this is kind of funky, a fraction within a fraction, right? So we don't divide fractions. Instead, we multiply by the reciprocals. So if we were to simplify, we would flip this. Or you could cross multiply, a little unorthodox with a fraction over a fraction. Well, 1 times 2 is 2, and 1/2 times 4 is 2. So yes, these are proportional to each other. Awesome. Okay, so your turn. Try this one. Does the following table represent a direct variation? All right, so I need help from the studio audience for this one. What do you think here? Alex Bergman. Does this table represent direct variation? How do you know?
I guess.
Okay, well, we need more than I guess. First of all, Alex, what does direct variation mean? Does that mean the same thing as proportional?
No.
Well, we learned a second ago, actually, Alex, that direct variation is one of those 3 phrases that does mean the same thing. So don't worry, don't let that trip you up. It still means to be proportional. So how do we prove if a table is proportional, just like we did in the previous example? What do we do with this table to take some numbers?
Take 2 of them and divide them?
Yeah, we're going to grab 2 points. So give me 2 coordinates from this table, Alex.
1/3.
1 and
And
3. Okay, so that's the
3/6.
coordinate 3, 1. And you want to take the coordinate, well, let me back it up. That's not 3, 1. I'm going to confuse people. That's the coordinate 1, 3. You said 3, 6. Okay, so let's take their y values and put them on top. So we've got 3 over 1 and 6 over 3. Are those 2 fractions equal to each other, Alex? How can you prove it? Well, let me ask you this, Alex. What is 3 over 1 simplified to?
3,
Yeah, how about 6 over 3? What is that simplified to?
2.
Yeah, those are not equal. So therefore, this is not proportional. And it's as simple as that. Nice job. Thanks for volunteering. So write down this equation in your notebooks. This is what proportional equations will look like. Y equals m times x. Hey, what's missing here that we normally have for a linear equation? What normally comes after that mx?
Plus b.
Plus b. But why is that b not in this picture? Where's b? Why do you think it's just y equals mx for proportional? Where's b? Do you remember those graphs that are proportional where the line crosses through? What's the y-intercept of proportional graphs? Where does it cross the y-axis? At what value?
The origin.
The origin, which is a value of 0, right? So b equals 0. That's why you don't see it in this equation. So you might see like y equals 2x. Well, I wouldn't write 2x plus 0, right? So we just don't write it at all. So that would be an example of a proportional equation, just like that. Okay? All right. So proportional equations will just be y equals a number times x. The y-intercept is 0. Okay, so we're taking our poll. Go ahead and access the polling icon and make your vote. All right, next, we're going to go to number 2. Which table represents a direct variation? So which one of these tables represents a proportional relationship or direct variation? So remember what we did with the tables. We compared y over x from 2 points from each table. So with your eyes, maybe you could do a quick comparison of y over x and see if any of these tables have proportional or direct variation. Make your choice. You've got about 10 more seconds. Then we're going to go to the final question. All right, question number 3 is coming up on the screen, so make your decision for 2. All right, which equation does y vary directly with x? So which equation does y vary directly with x? Or in other words, which equation represents a proportional relationship? Remember what we said proportional relationship equations look like, what the value of the y-intercept was. Make your response right now, A, B, or C, and then I'm going to close the poll. Yeah, you have 10 seconds to choose your response. 5, 4, 3, 2, and 1. All right, I'm going to share the polling results, but before I do, ask yourself, can I identify a proportional relationship from a graph, table, or equation? Let's take a look at our results from the poll. So I think you can view these. Number 1, which graph represented a proportional relationship? The majority of you chose B. Let's take a look real quick at that graph. Let's go back in time here. The correct answer is B because it passes through the origin. Number 2, which table shows a direct variation? The majority of you chose B in this one as well, and you would be correct because B shows y divided by x is equal throughout the whole table. So B for number 2. And then number 3, which equation shows y varying directly with x? The majority of you chose B here, and you would also be correct if you chose B because that one is y equals a number times x with a y-intercept of 0. Very good. Okay. All right, excellent job. I'm going to stop.